Welcome to the deep dive. Today, we're really jumping into some surprising global climate dynamics. We'll be looking at this rare Atlantic Niña event and what it might mean, maybe unexpectedly, for the 2025 hurricane season. And then we'll zoom out a bit, look at the long-range signals for winter 2025-2026. Our sources for this deep dive, well, they really show how interconnected all these global systems are.
Absolutely. And that interconnectedness, it's really the key thing here. Understanding how something happening in one ocean basin can ripple outwards, affecting weather patterns way over continents away. That's vital for you to, anticipate and prepare.
Okay, so let's start with this Atlantic Niña. We hear loads about El Niño and La Niña in the Pacific, right? But in Atlantic Niña, what exactly is that?
Right. So Atlantic Niña is basically the cold phase of something called the Atlantic zonal mode. Means you get cooler than average sea surface temperatures, SSTs, in the eastern part of the equatorial Atlantic. Usually that's driven by deeper water coming up, and upwelling and strong trade winds.
Okay, standard picture. But you said this current one is unusual, rare even.
Yeah, this one is pretty unique. It kicked off really fast. Strangely, the southeasterly trade winds near the equator were weaker than you'd expect in some areas. Weaker winds should mean less cooling, right? But the surface still dropped significantly, like 2 to 4 degrees Celsius. And the real kicker is the subsurface water, maybe 25 to 50 meters down. It's actually stayed warmer than normal. So that tells us, unlike a big Pacific La Niña, this one doesn't have deep roots. It's likely short-lived.
Which leads us right into the hurricane season outlook for 2025. Because it feels like a paradox, doesn't it? Atlantic Niña, you just said, cooler water, weaker ITCZ, conditions that are normally less ideal for hurricanes. So why are the forecasts still pointing towards an above-average season?
Yeah, it's a great question. The thing is, this Niña is expected to be temporary. The main factor, the thing overriding it, is the forecast shows a rapid flip back to an Atlantic Niño event, the warm phase. So warmer SSTs, weaker trades, lower pressure. Basically, conditions becoming much more favorable in the main development region. And this flip is expected right around the peak of the hurricane season.
Right. And the forecasts themselves, places like Colorado State, NOAA.
It's pretty consistent. CSU, I think, has 16 named storms, 8 hurricanes, 3 major ones. NOAA's range is 13-19 named storms, 6-10 hurricanes, 3 of 5 majors, both pointing to a higher risk of major hurricane landfalls for the U.S. and the Caribbean.
So multiple factors at play then.
Exactly. It's the expected Atlantic Niño, plus the Pacific is likely going ENSO neutral or maybe developing La Niña conditions. And just generally, the wider Atlantic sea surface temperatures are still warmer than normal. The brief Niña is just a blip.
Okay, so shifting gears from the immediate hurricane season, let's look further out. Winter 2025-2026. You mentioned interconnectedness. What about the polar vortex?
Right, the polar vortex is this huge area of low pressure and really cold air way up in the atmosphere, circling the North Pole. Think of it like a spinning top. When it's strong and stable, it keeps the cold air locked up north. But if it weakens or gets disrupted, wobbly, that cold air can spill southwards, towards us, basically.
Into the U.S., Canada, Europe. Okay, and the signals for this coming winter?
Well, we've got 3 big global drivers, all sort of pointing in the same direction, towards a weaker or more disrupted polar vortex.
3 drivers, what are they?
First, the Pacific ENSO situation. It's neutral now, but forecasts increasingly suggest La Niña developing into fall and winter. La Niña often correlates with a weaker polar vortex, so that's one signal.
Okay.
Second, the QBO, the quasi-biennial oscillation, this wind pattern high up. There's a new easterly phase coming down, and it's expected to strengthen. Easterly QBO also tends to favor a weaker vortex.
Right, number 2. And the third?
Arctic sea ice. Specifically, the extent in the Barents and Kara Seas, north of Scandinavia and Russia. It's currently very low there. And that pattern is considered, almost a textbook setup for weakening the polar vortex. Interesting. And what's really fascinating is that this sea ice effect, it's much stronger when you also have an easterly QBO. So they're not just adding up, they're sort of amplifying each other. It creates quite a strong combined signal.
Wow. Okay, so a weaker vortex is looking more likely. What does that actually translate to for winter weather?
It suggests a more dynamic winter. More variability, swings in temperature, and precipitation. For you in the northern U.S. and Canada, probably colder overall, stormier, more chance of significant cold outbreaks, more snow. The southern U.S., though, tends to be warmer and maybe drier in these setups.
And Europe?
Europe could see more variability, too. Maybe an increased risk of strong windstorms, perhaps flooding, or heavy snow events in places. Often linked to what we call a negative North Atlantic oscillation, or NAO pattern, which itself is sometimes linked to a weaker vortex.
It really highlights how these systems connect. Which brings up a final point. How does this Atlantic zonal mode, the Atlantic Niña, compare to the Pacific ENSO we hear so much about?
Good question. There are similarities, yeah. Both involve ocean-atmosphere coupling, trade winds, upwelling, warm and cold phases that impact global weather.
Yeah.
But there are key differences. Generally, the Atlantic events are less intense, they're more localized, don't last as long, and critically, they tend to peak in the northern hemisphere summer, whereas Pacific ENSO peaks in our winter.
So not just a mini ENSO.
No, definitely not. It's its own distinct climate pattern with its own dynamics. Important to remember that.
Okay, so let's bring this all together. We've seen this rare, maybe short-lived Atlantic Niña, but it's part of a much bigger picture influencing the hurricane season and potentially linking into signals for a dynamic, maybe colder winter for some next year due to a potentially weaker polar vortex. It really shows that dynamic interplay.
It really does. And I think, in a world just full of complex climate information, understanding these connections, how these different forces interact in nuanced ways, that empowers you not just to watch the weather happen, but to actually anticipate and maybe prepare for the kinds of patterns that might be ahead.